Hey guys, so we are starting a new unit, and the best news is there's no singing yet. I don't know any singing that goes along with this unit. So we're going to look at exponential functions, and this is the intro notes. So we're just going to touch a little bit of the information and talk about what we're looking at here. Okay, so what we've already discussed as a quick review is we've discussed linear functions, right, which are a straight line. Okay, so that's linear. We have discussed quadratic. Oh, yeah, with that awesome song, and that's a U shape. So now we're going to do exponential functions. And exponential functions are a curve. Okay, so we're going to make a slight curve. So let's talk about our information. So here is our equation. The A value is the initial value that you're starting at. So on an investment, it would be your initial amount. Okay. The B value right here, the B value, well, let's go right here for X first. X is the exponent. This is generally the amount of time that goes into it on a lot of these problems. So we'll talk about that, but notice that the variable X is actually the exponent now, okay? The B value in this one is actually the base. So the X is the exponent is the X. The B is the base. And what the base is it's going to be your growth or decay. And here's the big term, factor. There's a difference between the factor and the rate. Okay? We're going to talk about all of that good stuff. And then Y is just your amount or your total. Okay? So depending on, we will probably use that interchangeably. Now, if you look at the PowerPoint, this is all going to just kind of fly in on the PowerPoint. That's what we're going to do in class. So you'll be following along like that. Okay, and an exponential growth function. So growth, what do you think happens? It means it goes up, right? A is still the initial value or the initial amount. So it is going to be the initial amount or value. And B is always greater than 1. Okay, so greater than 1, just as a reminder, it's greater than 1. Okay, it's always going to be more than. For decay, what do you think decay will be? We know that A is that initial amount or that initial value of whatever you're looking at, the bacteria, the money in the investment. B is always, and I say it like this, between 0 and 1. It's going to be between 0 and 1. And let me rewrite that with the word and on there for you. It's going to be between 0 and 1. So it's going to be a fraction. It's going to be a decimal, basically. And what that looks like in proper terms is that B is between 0 and 1. And none of them are equal to 1. 1 means it doesn't do anything. So you'll notice none of it's equal to 1. Okay? So what we're going to do here is we're going to look at the amounts and we're going to identify, okay, the stuff about it. Is what is the growth or decay, the initial value. Okay, is it a growth or a decay? What is the initial value and the growth or decay factor? So we're actually going to look at kind of like these. So we're going to look over here. And our first question we're looking at, is it a growth or a decay? So what you look at is you look at this first number and you refer back up here. Is it a growth or is it a decay? Is it greater than 1 or is it between 0 and 1? Well, it's greater than 1. So it's a growth. Okay. What is the initial value? That's our A value, which is right here, which is 3. And our growth or decay factor is the 1.8. That is all we are doing on these problems. That's all we're going to determine. Nice and easy to get started. Okay. So let's look at this one. Is it a growth or a decay? Since that's greater than 1, it is a growth. Our initial value is negative 2.1, so that positive or negative doesn't matter right there. Okay, we're just looking at the factor. And the growth factor, let me point that out too. The growth factor is going to be 1.04 because that's just slightly larger. It's slightly larger than 1, but that still means it's growing. It's still getting better or bigger, excuse me. All right, let's look at 3 and 4. Number 3. Okay, so is it a growth or a decay? So I'm looking at my B value, and my B value is between 0 and 1. So it is a decay. My initial value is the first number, which is a 9. And my decay factor, would be a 0.8. There's a difference between a decay factor and a decay rate, and we're going to talk about that a little bit after this, okay, in another section, okay, in the next section. So right now we're just getting to know it. All right, so then we're going to go over here. Is this a growth or a decay? Well, it's less than 1. It's between 0 and 1, excuse me, so it's a decay. The initial value is -2, and the decay factor would be 0.94. So that's your B value. Just remember that growth or decay factor is your B value in the equation. So now we're going to move on and we're going to talk about that B value, that growth and decay factor. So if you look at the top of your paper, just so you don't miss it up here, it's the B value. So on the y equals A times B to the X, this is all about this little bad boy right there, okay? What are we going to do with it? So I'm going to come over here and I'm going to talk about growth first. Now, let's look at our two equations down here and let's see if y'all can tell me what the difference is. What do y'all see that the difference might be? Hoping you see that that's the plus and that's a minus, naturally, okay? Now, what does the 1 mean? Why is the 1 there? Well, as I told you, it's not equal to 1 because 1 times anything is still 1. It doesn't grow or decrease. 1 times 1 times 1 stays a 1. Okay, so when I add something to it, it starts to grow up. When I subtract something from it, it starts to get smaller because it's less of that amount. 1 is your perfect percent, basically. 1 is 100%. It is perfect, that perfect dollar, okay, that we want. All right. So we're going to look at kind of how you find this information, okay? So, and an exponential growth function, A is the initial value, B is greater than 1, okay? Or you can also say B is greater than 1. I want you to see the correct terminology. Then that means B is a growth factor. That is the factor. It is a growth factor. And the rate is something different. The rate, the growth rate is the difference from 1. What is the difference from the 1 value to find that rate? And so to find it, you will do B minus 1. Whatever your B value is, minus 1. Minus that perfect 100%. Okay, so we did 100% of it plus something else. Okay, plus a little bit more. So now we're going to go over here to decay, and we're going to talk about what decay is and what decay looks like. Decay, you still have your initial value, but your B is between 0 and 1. Okay. So B is going to be your decay factor. It is a decay. So again, we have that rate thing again. So let's talk about it. So the rate is still going to be the difference from 1. It is going to be the difference from 1. So notice they're both the same thing, but on this one, it's going to be smaller. So you'll do 1 minus the B value to find it. Okay, you're going to do 1 minus the B value. So the key is if it's more than, you're going to subtract that perfect percent. If it's less than, you're going to do the perfect percent minus, the $1 minus it. Okay, so it's all the difference from a dollar. Okay, so let's go look over here. So we're going to do the same thing we did on the other ones first. We're going to look at this and we're going to identify, is it a growth or is it a decay? Well, that one's greater than 1, so it's a growth. Its initial value is 0.2. The growth or decay factor is 1.5. So what is the rate? Here is what we're testing right here. The rate is the difference from 1. How far from 1 is 1.5? It is 0.5 from 1. That's the difference. So how do we do it? We did 1.5 minus 1. We did B minus 1, and we got 0.5. Okay? So if you can look at it and tell, that's fine. If not, draw that math down. Write that math. Okay? So let's look at our next one. Our next one is a growth. Oh, let me go over here. Sorry, I forgot to circle growth right there. Okay. The initial value is -6.8, so none of that changed. The B value, the growth factor, is still 2.04. And now it wants the growth rate. That's the difference from 1. How much is it growing over that perfect 100%? It's repeating once, and how much? So for that, you will do 2.04 minus the 1 leaves you $1.04 over 1.04. So it's 100.04% larger. Okay. So we did the B value minus 1. We are going to practice this before we go on to anything more complicated, guys. We are going to practice it. All right. So now let's go down here and let's look at our next one. Our next one is it a growth or a decay, guys? It's a decay because it's less than 1. Our initial value is negative 2.7. Our decay factor is 0.75. So I like to look at this as 0.75. So for our decay rate, how far is 75 cents from $1? How far is it from $1? It is 25 cents. So it is 25 cents. We are decaying by 25%. How would you find that? You would do 1 minus 0.75 or 1 minus the B value. Okay? Look at those notes. Depend on those notes. That's totally what they're there for, guys. That's what I plan on. So let's look at our last one over here. Obviously, it is a decay because it is less than 1. It's between 0 and 1. Our initial value is that 3.8. The growth or decay factor, so the decay factor is 0.98. How far from $1 is that 98 cents? How far from $1? It's 2 cents. And make sure you write it as 0.02. So 1 minus 98 cents is 0.02. So we do 1 minus the B value. And that's it. You just have your practice after this.